What if I told you that every map you've ever seen is wrong? I mean, mathematically doomed from the start. And weirdly enough, it's one of the clearest signs that the Earth isn't flat. Let's explore this. Hello there, welcome back to Star Stuff. If you're new to the channel, welcome. I'm happy you're here. Please have the time of your lives in my comment section. Maps feel simple. You take the Earth, flatten it, done. Cartographers are like, yeah, about that. Because for centuries, humanity has been trying to do exactly that and failing in increasingly creative ways. We're going to look at the core problem of this. You cannot flatten a sphere without distortion. Try peeling an orange and pressing the skin flat. It stretches, it tears, it warps. That's basically what happened when they invented the first inaccurate world map.
If I want to turn this globe into a flat map, I'm going to have to cut it open. In order to get this globe to look anything close to a rectangle lying flat, I've had to cut it in several places. I've had to stretch it so that the countries are starting to look all wonky. And even still, it's almost impossible to get it to lay flat.
So instead of one perfect map, we have map projections, which are different ways of translating a curved surface onto a flat one. The most famous one is the Mercator projection. Great for navigation, terrible for scale honesty. On this map, Greenland looks a similar size to Africa, but in reality, Africa is about 14 times bigger. I know, I live there. So Greenland's basically that friend that looks huge in photos because they stood too close to the camera. This specific problem only exists if the Earth is curved. If the Earth were flat, you wouldn't need projections. You wouldn't need compromises. You'd just draw it. Done. Cartography would be the easiest job on Earth, which, suspiciously, it is not. Instead, we have multiple projections. We have the Mercator projection, which keeps direction accurate. We have the Gauss-Peters projection, which keeps area accurate. And we have the azimuthal equidistant projection, which keeps distances from a point accurate. Each one sacrifices something. It's like trying to take the perfect selfie. You can have good lighting, good angle, good timing. Pick two. And this doesn't stop at world maps. Every map we use quietly depends on the Earth being curved. Yes, even the ones you trusted on hiking trips. Let's look at topographical maps. They show elevation using contour lines, like slicing the land into layers. They look flat, but they're built from measurements taken across a curved surface.
These lines connect all the points on the map that share the same elevation. By looking at how the contour lines spread out and come together, you can get a good sense of what the terrain looks like.
So technically, even your peaceful mountain hike is brought to you by spherical geometry. At small scales, you can pretend Earth is flat. Everything behaves nicely. But zoom out, that illusion collapses faster than my motivation on a Monday. And as you know, surveyors actually have to correct for curvature, or else their measurements start drifting. This matters in real life. Engineers building long railways, canals, bridges have to account for I almost said furniture. Have to account for curvature. Because over long distances, level isn't straight. It curves. Ignore that, and suddenly your bridge has commitment issues. Even latitude and longitude only work on a sphere. Lines of longitude get closer toward the poles. On a flat surface, that just doesn't happen, unless geometry itself decided to take a day off. GPS, weather systems, flight navigation, all rely on spherical geometry. Planes follow the shortest routes, which are great circle routes. On a flat map, those look curved. On a globe, they're exactly what you'd expect. So either pilots understand geometry, or they're just freelancing across the sky and hoping for the best. Now flip it. Flat Earth models try to use one map. Then distances break, Flight routes don't match. The southern hemisphere becomes absolute chaos. Meanwhile, on a globe, everything lines up perfectly. Almost like it's the correct model. So ironically, the fact that maps are distorted is exactly what proves the Earth isn't flat. Because if it were, maps would be simple. Perfect. Honestly, a little boring. But instead, they're complicated, slightly chaotic, and full of compromises. Just like trying to flatten a sphere. Next time you look at a map, don't think you're seeing Earth as it is. You're seeing the best possible compromise of something that absolutely refuses to be flattened. Thank you so much for watching. If you enjoyed this video, please like and subscribe. And if you'd like to support the channel further, you can now join to become a member. Last week I put up a post asking viewers for some topics that aren't explained clearly a lot of the time. So next week I'll be kicking off a series called Explaining the Hard to Understand Stuff. And you might recognize the guest I have on the first episode. So stay tuned. Cool beans.